Hello, everyone, and welcome to this lecture. So, in this session, we're going to try to discuss some of the fundamental concepts of machine learning. So, I want to start with data science, which is a multidisciplinary field that extracts insights and knowledge from structured and unstructured data. And so, data science blends expertise from statistics, math, and computer science and other disciplines to extract meaningful patterns and trends in the data. So, data science forms the foundation upon which machine learning flourishes. Understanding data is paramount for crafting and creating effective machine learning models, and it's disciplines like data science that allow us to follow the entire life cycle of data from collection to analysis to interpretation. And before I introduce you to the life cycle of data, I want to talk about another subfield of data science, which is data mining. And so, data mining is the process of discovering hidden patterns, trends, and insights within large data sets. And so data mining offers us this very important structured process called cross-industry standard process for data mining. So let's break it down into these steps in a straightforward manner for better understanding. So step number one is business understanding or understanding the business. It involves figuring out what the data mining project or task is all about. Are we looking to increase revenue, or do we need to identify the cause of a specific problem? So it's about knowing the background of the problem. And then moving on to step number two, which is data understanding. Here we collect data from surveys or from existing data sets. And so we need to know the different basics, like how was the data collected, what's the data format, the number of records, and so on. So this step is closely related to the first one, and we often go back and forth between understanding the business and understanding the data. Then step number three is data preparation, because most of the time the data we collect is not perfect. It might have the wrong format or missing values. And so in this step, we decide how to transform the data, considering options like taking the like reducing the number of features or attributes of our data to make the data, or taking samples of our data set to make the data set even more manageable. And so moving on to step number four, which is modeling. Here we choose a modeling technique to analyze the data. It's important to check if our data fits the assumptions of the chosen model or not. And sometimes we might need to go back to the data preparation step in case we notice that our model is somehow performing bad. We may assume that we didn't do a good job in the previous step. We didn't provide good quality data to our model, and that probably may be the reason why the model is struggling to learn the trends in that data. And so in step number five, we evaluate the model. So we use assessment methods and metrics to determine if the model meets the objective of the task. And if not, we might need to revisit and go back to earlier steps. And then finally, in step number six, we deploy the model. This means we put it to use to achieve those business objectives that we identified in step number one. And so I do teach another related course called data mining, and that specifically discusses these steps, right? It's mainly about data understanding and data preparation. Whereas for this course, which is machine learning, we will be focusing mainly on the modeling and the evaluation aspect of this process. And so before we get to the modeling step, we need to understand data itself. So data comes in different shapes, different formats, different types. So there's two main categories of data. We talk about structured data, which has some sort of defined and precise format or structure. Example, when we are talking about tables in a database where you have sets, specifically relational databases, for instance, where we have sets of rows that are defined with a number of attributes or features. So that is structured data. The other category of data is unstructured data, where we do not have a precise format that the entire data set follows. So it's kind of a freestyle type of data where you can have a mixture of images, video, audio, textual data, and so on. And in between, you may find what we call semi-structured data. And as an example of that, we talk about data formats like XML and JSON. They're not quite structured as of database tables, but they do have a specific format or structure that the entire data follows. We can also make the difference between private data and open source data. So private data is local to that organization or institution, and it's not allowed to be shared outside it. Example of private data when we discuss patients' records, for example, it's private and local to the healthcare provider. Versus with open data, it's data that's openly available to the public to use for research purposes. They can access it, download it, modify it, and so on. So this leads to this list of sources where you can find open data. And so you will need this specifically for the final project where you are required to choose a data set to apply machine learning models and techniques to it. And so this is a list of some of the sources where you can find data, and I highly recommend Kaggle as a source of data sets. So you can go to this website and then search for any discipline or topic you are interested in, and it can give you a list of related data sets that you can freely download and start pre-processing and building models on. The other two categories of data is labeled versus unlabeled. And so data can come with labels, meaning we already know what that data is about. For instance, I have imaging data and I already know that the label for this image is a dog and the label for this image is a cat. Or for instance, I have access to these images, but the label is actually the weight. So this is 14 pounds, this is 9 pounds, and so on. Sometimes we do have access to large amounts of data, but it's unlabeled. It doesn't have specific annotation or predefined category that it belongs to. So it's just data, but without labels. So with labeled data, we can build classification models, right? We discussed classification as a type of machine learning technique. And then we can also build regressors, right? We can build regression models with labeled data. Whereas when we have unlabeled data, we can build clusters, right? We can apply clustering algorithms. So the input to our machine learning models will be data that consists of a set of what we call instances or data examples or data samples. So if, for instance, we are building a image recognition model, then each image is called an instance, okay? And so then each instance is characterized or defined with a set of features. So, or also sometimes called attributes. So it is those characteristics that define each instance and make it different from another. So if we are building a disease diagnosis model, and then the instances will be the patients, and then the features will be the different data collected about each patient, like the age, the weight, the previous medical history, sex, and so on. So all these are different features that do characterize our patients. So features now come in different formats. In our course, we're going to be dealing with two main types or formats. The first is numerical data. So any feature like the age, the weight, the shoe size, or the number of children, these are numbers. So that's a numerical feature. The second data format that we will be dealing with in this course is the categorical form. So anything that's text, that's made of word. We mainly going to be interested in nominal data formats. So things like when we label an object in an image with labels like cat, dog, chair. So all these are words, they're categories, okay, and they're nominal. The other type, there's other different subtypes of these two, but we will mainly focus on numeric versus nominal.